Hello, we are Tuple Coders, and now I'm going to present to you our project 3D LiDAR color compression and feature extraction. This project is sponsored by Dr. John Pimiani and Dr. Anshuman Razdan. Now, first of all, what is LiDAR? LiDAR is an acronym for light detection and ranging. It is a technique in which the distance of the target is measured by illuminating the target with laser and then analyzing the reflected light. The reflected light contains a dense set of data points. Now in this video, as you can see, this truck is mounted with a LiDAR system and it scans the area in its surrounding. The green portion is the area that it is surrounding. Now the main problem with this technique is that it captures a huge set of data. For example, for about 1 square mile, it captures about 2.3 TB of data, which is very huge. Now in order to access this important and very important resource, we need to compress this data so that we can access these LiDAR files. So now here our plugin comes into picture. These are the following operations that our plugin can perform. For example, first of all, the compression, 3D visualization, conversion to other formats, controlling the resolution and extracting the information. Now we'll show you the demo of our plugin. This is QGIS. QGIS is Geographical Information System software, which is used to analyze as well as view the data. This is our plugin, LiDAR processor. This is the GUI of our plugin. First of all, we'll select the input directory. Input directory is one in which the LAS files are present. Now I'll tell you, LAS is the industry standard representation of storing the LiDAR files. So first of all, I'll select the input directory and then the output directory in which the output will be directed to. So here is the output directory. And now I'll select the LAS tools directory in which the LAS tools are stored in the user's system. So this is the LAS tools directory. I'll select this. Now as you can see from the drop down box has picked up the files that are present in the input directory. These are the two files that are present, and we can perform these operations, visualization, compression, DEM generation, etc. on any number of files, on selected file as well as on all the files. So first of all, I'll select selected file only and select one of these files and click on visualization. Now as you can see, a 3D view has been popped up on the screen, and this view this is a 3D view of the LiDAR file. So zooming into this file gives a clear picture of the view. Now I'll pan the file, and here we can see there is a road which is surrounded by some trees and some poles. So this is the 3D visualization of the data. Now moving further, I'll perform all the operations on all the files on the directory. So first of all, I am changing the input directory because it contains files of smaller sizes due to the time constraints. Now I'll compress the files and generate the DEMs of the file using the customize resolution button. I'll enter some values. Click on start message. First it will compress all the files and then it will generate the DEMs file. DEMs are digital elevation models, and these models are generated in two formats, ASU formats and TIFF formats. These both the formats are used in the further operations of our plugin. So right now it is processing. So right after it will process, a message will appear in the status of operation box. Yes. So as you can see, for the compression ratio is set for each and every file. So it is about 10 to 11, which is very good. And after that, the DEMs have been generated with the following resolution. Now we can also generate the DEMs with the default resolution. If we click on start version, it will regenerate the DEMs file, but now these files will be generated in the default resolution. So once again the DEMs will be generated, and these DEMs will replace the earlier DEM files, and the DEMs are being generated right now. I'll show you the output folder in the meantime. This is the output folder, and as you can see, there are all the files that are generated, ASU files, TIFF files as well as LAS files. So now the DEMs have been generated, and now after the DEMs have been generated, we'll click on shape generation and generate the shape file. So the shape file has been generated named merged file. It is formed by converting all the 3 files into one file. So now we'll load this file over QGIS. So by clicking on load layer, as you can see in the background, the file has been loaded in the QGIS legend. Its name is merged file. Now to generate the tile index, there is a built-in plugin named tile index, and you can click on show tile previews in map. It will generate a transparent tile index of these files. These can tell you the boundary of each and every file. Now we can also load the corresponding dem file that we generated over these files. So as you can see, each and every dem file is being loaded over the QGIS over these files, and these are not exceeding the boundary. Now if we want to view these the last file of these corresponding ASU files, we can also do that. We have a plugin named LiDAR last viewer which does this for us. So we will click on last view. It will ask for the last view directory. So for the first time we have to provide the last view directory to it. So if I selected yeah, so if I select this directory, it has the last view in it. If I click on OK, then the last view is again generated. This is a 3D visualization of this file that we have generated. This is also a 3D view, but as this size of the file is less, so there is very less 3D component in this file. Thank you, and that's all from us.